So, hi everyone. I am a data engineer by profession, and I decided to start a series to learn about Apache Spark in depth. So, today we will be starting with the first session of it, where we learn about what exactly Apache Spark is, basically, getting into the literal definition of it. So, let's begin. Big data and Apache Spark. So, whenever we hear about big data, we might have heard about many different tools like Hive, Hadoop, etc. and all right, and Apache Spark as well. It's like these two are interrelated for processing each other, right? Apache Spark basically makes handling big data quite easier. So, as I have mentioned here, it's like a superhero for data processing. Like imagine having a tool that can process huge amount of data really fast, and also allowing you to analyze it and at the same time use it quite quickly. That's what Apache Spark does. In times we have many data, right? Like I said, with Apache Spark, tasks that used to take forever, I mean a lot of time, can now be done in a short span of time. Plus it's quite easy to use and anyone can learn to use it. All right, we will be getting to learn more about how to use it and how to integrate it with other languages later on in the series. So as of now, it's just this. Just know that Apache Spark is quite a huge and important part of processing big data, and also the most effective one till date. So let's get into the literal definition of what Apache Spark is. So as you see here, Apache Spark is a unified computing engine enabled with set of libraries for parallel processing of data. So to understand this quite effectively, we will be learning the meaning of each and every word that forms the definition of Apache Spark. Alright, now if you look closely, these keywords are all related to the processing of data. And to understand Apache Spark quite easily, it is very important that we get to learn the process that goes behind the scenes when data is being processed through Apache Spark. All right. So let's start to understand each of these words separately. All right. What is unified? I mean, in literal English terms, we all know what it means, right? Unified means it can do a lot of things, or a lot of people can use it in simple terms if you call it. So basically, as you can see here, Spark is designed to perform a wide variety of tasks in one platform or a computing engine, or you can say unified. All right. So let me simplify this for you. All right. So anyone who is working with data may have heard of these three terms or roles that usually deals with data. All right. In simple terms, you can say that data engineers are the one who are responsible for building pipelines of data. Data analyst basically interpret the data, or you can say analyze it, that are provided by data engineers, or most of the time they retrieve that data themselves. And data scientists are basically, they make models, or I would say that models to predict what the next best product is. Let's say about that. So let's talk about a product that you have. Data engineers would be responsible for collecting all the information related to that product, the sales, the numbers, etc. All right, these details would be provided to a data analyst, and data analyst may help you provide insights to that data, that how the sales have been doing and how many products have we sold, etc. and etc. All right. And now, data scientist, his role would be to get that information and to use it to predict the further sales of it, so you can modify your products or marketing based on that. So this was a literal definition of what these people do. I mean, these roles basically are involved with. So the my point here is, all these roles can make use of Spark for their processes in one way or the other. In simple terms, Spark is unified. But the term that we were looking for in the definition was unified computing engine. Let's first understand the meaning of computing engine in our next slide. All right. What is computing engine? All right. Um, in simple terms, you can call it like you might have all learned in elementaries, like CPU is the brain of the computers. And that's what computing engine means. It's basically the part that does all the thinking and calculation. Just like our brain processes information, right, to help us keep decisions and stuff. That's what computing engine does. It processes the data and provides result. All right. Before getting into a definition of it, there's one important part here, as I have mentioned here. Computing engine of Spark. Let me be very clear here. The Spark computing engine we have, what it does is, all right, some issue with the typing here. Anyways, so Spark computing engine, it just computes data. Spark does not store data. You keep this in mind. It's a very, very important part that most of us seems to be confused about. Even I was confused at first, so I think it's necessary that I mention here. To store data, Spark can connect with all other data storage or source systems like HDFS, cloud-based storage, and etc. All right. So basically, let's go back to understanding computing engine. So in simple terms, let's say that if you give computer a task, right, such as adding two numbers, this is quite a small task, but let's say that it is okay. So adding two numbers or sometimes analyzing a large data sets, right? The computing engine will take the input, it will perform the necessary calculation or operations or whatever the input needed was, and then produce the output or result. Okay, and Spark does the same thing. In simple term, whatever is being computed in Spark, I'm explaining it to you in terms of storage and stuff. All right, whatever is being computed in Spark is handling in the RAM, let's say, and as soon as it done, it vanishes, it doesn't store it. So keep this in mind that Spark is a computing engine and it does not store data. All right, so now we have a basic understanding of what computing engine is and what Spark computing engine is. And to keep that in mind, Spark computing engine computes data. It does not store data. All right. Now, to gain a deeper understanding of yet another part of Spark, we need to understand what parallel processing is, because that is the most important feature of Spark. What is parallel processing? So, in literal definition, parallel processing refers to the simultaneous execution, and by that I mean side by side execution of multiple tasks or instruction to achieve a faster and more efficient computation. All right. Instead of like if you want to do work sequentially, let's say one person has to do a huge amount of tasks. If he does it alone, then it may take him more time than what he does with a whole team. I'm not talking about a development task that sometimes seems to be divided within teams and results are expected to be done faster. That's not what I'm talking about here. Let's say, in simple terms, instead of completing tasks sequentially, parallel processing divides the workload among multiple processing units, allowing them to work concurrently. So, parallel processing is not performing tasks simultaneously, rather concurrently. All right. The approach significantly reduces the time required to complete complex computation, making it quite the essential part for handling large scale data processing. And that's what makes Sparks the most efficient tool for parallel processing of data, i.e., handling big data. It basically, so parallel processing you can understand in the next slide. I'll be explaining it to you how it is distributed and how each executor receives a task, how it reports it back to the master. We will be gaining a huge in depth of parallel processing. This will be yet another slide because it's quite an important part of what parallel processing is. All right. So to gain more insight, I will also give you an overview of what computer clusters are. All right, here you can say computer cluster. The word cluster itself means a group of something, right? So here it basically means a group of interconnected computers. All right, often in terms of Spark it's refers to as nodes, and inside nodes, all right, these nodes or the cluster or computers, they work together as a single unit to compute data. All right, clustering basically allows multiple computer to operate collaboratively, sharing resources such as the processing power, the memory, the power, memory storage, and some networking capabilities. Okay, so let me explain it in way more simple terms. As you can see here, we have a master and we have a slave. All right, its goal is basically to divide the task, and hence following this approach, if you have a task and you give it to the master, all right, the task is always given to the master, and the master decides how to split that task within multiple slaves, so that, let's say you have a large amount of data and you want it processed, master will divide that data between all other slaves while each of them are processing it on their own and then reporting it back to the master. Okay, this is how the computer cluster work, and that's the main process of what Spark follows to compute data. All right, we can see the simple example here. All right, let's say we have slaves here, and each of it has, as I have written a simple example, each of they have the single 16 GB RAM, 1 TB storage, and 4 core CPUs. All right, CPU cores, my bad here. And we have a task of 4 TB to be given. 4 TB is the task, or I would say amount of data that needs to be processed here. All right, so what to do when we have a big task? We basically divide it into different chunks. I'm talking about in real life examples. If you have a huge task, you divide it into smaller parts to get it completed on time. That's what Spark does. You have a huge amount of data, you divide it and assign the work to each of the slaves. They perform the work and they give it back to the master, hence making it possible to have a parallel processing going on. We will be getting into very in depth of this concept in the other coming slides. Now, since we have basically done a complete overview of each of the word, let's go back to the actual definition of Spark that we had. Apache Spark is a unified computing. It can be used by many, it can perform many tasks at once, and multi-purpose, you can say. Unified computing engine, it computes the data, it does not stores it, enabled with a set of libraries. All right, we didn't get into the in depth of what libraries are. So many of you who have worked with Python, or someone who haven't also, let me give you a brief definition of what libraries are. They are basically set of codes that are already inbuilt that makes your work easier. All right, like we have pandas for data processing, it basically forms a data frame and makes it quite easier for you to do any task on data and so on. So libraries is just that, libraries for parallel processing of data. We did get into in depth, right, what parallel processing is. Basically dividing tasks to multiple nodes or clusters so that the task is done in a lesser amount of time. So for today, what we covered was just an overview of what Apache Spark is, its literal definition, and some terms that you need to remember. We will be getting into in-depth of these terms in the upcoming sessions. All right. So that was all from me today. Thank you so much for watching. If you have any recommendations for what should I cover next, or if you have any suggestion what could be improved, please leave them in the comment sections. So bye. Have a great day.